So I've named this video more kinds of functions, but really it's more ways of seeing functions, more ways of visualizing functions, more ways of writing functions. It's all kind of the same function though. So I want to start this with a little bit of trip down memory lane. Recall a function with a domain of A and a codomain of B can be written as sets of ordered pairs. It can be written as the element xy are in the Cartesian product A cross B. Remember A cross, and then again, right? With, let's not use that sort of shorthand yet. Right? Specifically where f of x equals y. Okay? So remember relations, just like functions, because functions are just specific cases of relations. Certain relations are functions. So all functions are just a relation. Anyway, functions are they're just the sets of ordered pairs, basically. Okay? And we have intentional definitions of functions most of the time. Our regular function definitions are intentional. But you could also have an extensional definition of a function, which I don't think I'm actually going to give you one of those yet, but we'll talk about them later. Let's start with an example. So consider the function f, where its domain is z7. We haven't introduced that term, so let me do that real quick. When I say z7, I mean the integers up to 6, starting at 0. Now this might seem a little silly because it doesn't have the number 7 in it, but essentially it has to do, it's very commonly used in a lot of algebras for with modulos. All right. So it takes z7 and it goes to z5. So z5, the integers between 0 and 4. Okay. And where f of an input, x, is going to be 3x mod 5. Again, you could also see that written as 3x mod 5 this way. That's another very common notation. This is how we're going to write it. So the question is, multiple questions. First step is essentially an extensional definition of the function in table form. So what are the inputs and the outputs for this function? So inputs are some letter n, the outputs are f of n. The inputs are going to be 0 up to 6. The inputs are always going to be the whole domain, because one of the requirements for something to be a function is that everything in the domain has somewhere to go. All right? The image of every element in the domain is not empty. Okay, so let's look at this. We'll do the first one together, and then it's a good idea to pause the video and keep on doing some more. So let's see. So let's look at f of 0 real quick. F of 0 is going to be 3 times 0 mod 5. And remember, the modulus is essentially the remainder when you divide it out. So 0 divided by 5, what's that remainder? Well, the remainder is 0. Okay, so f of 0 is 0. Similarly, what's f of 1? Well, that's going to be 3 times 1 mod 5. So that's going to be 3. 3 mod 5 is 3. And then what is f of 2? F of 2 is going to be 6 mod 5, which is just 1. F of 3 is 3 times 3, which is 9 mod 5, which is 4. F of 4 is 12 mod 5, which is 2. F of 5 is 15 mod 5, which is 0. F of 6 is 18 mod 5, which is 3. And if we expanded our domain, you would get this cycle. Cycle repeats with period 5. It repeats every 5 numbers. 5 because it's mod 5. So this is what the function looks like in tabular form. I feel like I'm like writing the word Google or something. Doesn't that change colors like this? I don't know. But that's what the table looks like. That could be a way of extensionally defining this. We could also plot the graph. We're used to graphing functions. You've graphed functions in math class all your life. Well, maybe not all your life, but you've graphed a lot of math functions. You can do it here. The inputs are going to be the x's. And actually, we don't need arrows here. The inputs, right, are z7. We're not going to write all real numbers here. This isn't the real number line. It's just z7. 0, 1, 2, 3, 4, 5, 6. That's the last input. The codomain is what we'll put on the y-axis. That'll be z5. That's just 0, 1, 2, 3, 4. All right, we just plot the ordered pairs. 0, 0, 1, 3. I actually want to use the same colors. 0, 0, 1, 3, 2, 1, and then 3, 4. And essentially that would repeat forever. Wait, no, we have one more, right? Yeah, 4, 2, and then it repeats. Wait a minute, what happened? Yeah, 4, 2 is right here. Whew. And then it repeats with 5, 0, and then 6, 3. And again, if we expanded the domain, this would be a periodic function, just like sine and cosine and stuff like that. Be a periodic function. It's a discrete function. It's not a continuous function. Should not be surprising that we have a discrete function in the class called discrete math. But yeah, it's a discrete function, not a continuous function at all. But that's what the graph looks like. So you can have graphs of discrete functions as well as typical continuous functions. And then we also have something that we're going to call an incidence matrix. And I'm not going to fully define an incidence matrix, but I will just show you what it is and have you finish it. So lo and behold, shouldn't be a surprise, the incidence matrix is a matrix. You should have had experience with matrices in your time here. So an incidence matrix is a matrix of zeros and ones. And then this, right, is our domain. And this is our codomain. So it's just essentially a binary way of representing this information. It's a very good way of seeing whether something's a function. So we have the ordered pair 0, 0, which means 0, 0 gets a yes value, an on value, right? This is a computer science class. You're very comfortable with ones being something and zeros being not that thing, right? 1, 3, and then 2, 1. So 1, 3, 2, 1. And then 3, 4, 4, 2. Oh, I know I'm going to mess this up. 3, 4, 4, 2, 5, 0, 6, 3. And everything else in this matrix is a 0. So one of the nice things about incidence matrices is it's very easy to quickly determine whether something's a function. It's kind of like a horizontal line test, which is a little weird that it's different, right? Does every input only have one output? Does every input only have 1 0 in that row? If so, then yep, it is a function. So this is the incidence matrix for F. I don't know how much we're going to talk about incidence matrices in this class, but there it is, just in case. A little bonus for you. Let me know if you have any questions. That's the basics of functions. I'll have more on functions and relations in the next set of videos. Enjoy.